and welcome to Conversion Factors and Dimensional Analysis. Dimensional analysis is a very helpful problem-solving technique. A lot of times we do simple one-step problems, but what we find in chemistry sometimes is that there are multi-step problems, 2, 3, 4, 5, that we might actually better employ a different problem-solving technique. Conversion factors and dimensional analysis can actually be used in any science and are an extremely helpful problem-solving technique. So we're going to start first by talking about what a conversion factor is. A conversion factor is actually a fraction, only it's equal to 1. The reason it's equal to 1 is because you have a quantity on top and a quantity on the bottom that are equal. For example, there are 1,000 meters in 1 kilometer. So when I write this factor, if I multiply something by this, I'm really only multiplying it by 1. Now, of course, mathematically, when I punch things into my calculator, it's not exactly what I'm doing, but I'm not changing anything's value because this really just means 1. There are 1,000 meters in a kilometer, therefore, they're equal quantities. The same thing over the same thing is 1. I can also write this like this, which is really helpful. By writing this like this, in certain problems, it might actually help me to change from one unit to another. I do want to make a really important note here in terms of significant figures. With a lot of conversion factors, especially metric conversion factors, these are exact numbers. This is going to be the case most of the time, and this means we have unlimited sig figs. So when you're actually doing math with these, the conversion factors themselves are not what are going to be limiting the sig figs in your answer. So if I wanted to write a couple of conversion factors for centimeters and meters, hopefully you remember that there are 100 centimeters in 1 meter. So we can either write this as my 100 centimeters on top, or my 1 meter on the bottom, or 1 meter on top and 100 centimeters on the bottom. And the way that I'm going to write it is really going to be based on the problem that I'm solving. So let's start with a few examples. These are very useful in conversions. So a great example, we have the mountain goat run that happens here in the Syracuse area. We wanted to convert the 15-kilometer mountain goat run into miles, and we knew that there were about 1.61 kilometers of 1 mile. So we could say, all right, for our conversion factors, we have 1.61 kilometers over 1 mile. We could also have 1 mile, over 1.61 kilometers. This conversion actually is not a great example of one with unlimited sig figs, but it's kind of a fun local problem to do. So our starting amount is our 15 kilometers. That's what's given to us in the problem. I often like to think about what unit I want my ending amount to be in. So I like to come over here and say, okay, I want this to come out in miles. I'm going to show you these with parentheses also, but this picket fence way of doing this is kind of nice. Just start with a line. Everything's going to look like a fraction, so that's kind of nice. And then instead of like parentheses, you just kind of use little lines to separate things. So since I have kilometers on the top, okay, meaning I have kilometers right here, I need to get rid of kilometers. So I need some kilometers down here on the bottom. So I'm going to pick the conversion factor with kilometers on the bottom, which is this guy right here. So I've got 1 mile on top, and I've got 1.61 kilometers on the bottom. Now, what this looks like if you're doing very official dimensional analysis, I'll just kind of write this below so you can see it. You would actually write 15 kilometers times this fraction. And when you write things like a fraction like that, you have this on top, this on the bottom. Picket fence way kind of makes things a little bit quicker and easier, so you're absolutely welcome to do that if you want to change later to parentheses, whatever works best for you. So what we're actually doing mathematically here, we're canceling out these kilometers. So mathematically speaking, I'm actually doing 15 times 1, okay, and then I'm going to take that amount and divide it by 1.61. So I'm really just combining this whole thing. And what that's going to give me is 9.32 miles. So you end up doing 16 divided by 1.6. So I multiply across the top, then divide it by the bottom. If you want to check my significant figures here, I broke the significant figure rule. Because I only have two sig figs right here, guess I can't keep all of these, so let's change this to 9.3 miles. If I want to convert between centimeters and kilometers, this is very, very useful. And I'm going to actually do this in two steps. I'm going to start with my 245 centimeters. And I want this answer, my ending amount over here, to be kilometers. Now, I don't know exactly how many centimeters are in a kilometer, but I do know how many centimeters are in a meter. Because I have centimeters up top right here, I need to have centimeters on the bottom. So one thing I do know is that there are 100 centimeters in 1 meter. What that's allowed me to do is now get rid of my centimeters. And sometimes it's helpful to cross out as you go along. Next, I say to myself, okay, I need to get to kilometers. I got meters right here, which means I need meters right here to get those to cancel. And I know how meters and kilometers relate to each other. There are 1,000 meters in 1 kilometer. So now my meters are going to go away. I'm going to multiply across the top. So 245 times 1 times 1. It's pretty straightforward. So mathematically, I'm doing 245 divided by 100 times 1,000. And when we do this math, you should get a number that's very small. Kilometers are really big, centimeters are really small. So it makes sense that we're taking a number and we're dividing it, moving the decimal place to the left quite a bit. So what we're going to get for this is 0.00245 kilometers. That's good to go with my sig figs. Keep in mind that in terms of significant figures, these are all unlimited. The reason for that is I could call this, if I wanted to, 1.0000 meters. This conversion factor is made to be exact, to actually keep things a little bit simpler. To be technically correct, I could write this in scientific notation. It would be 2.45. Move my decimal 1, 2, 3 times. Boy, that answer looks great. You can also use these for general problem solving. So, for example, if you wanted to drive your car somewhere and wanted to figure out approximately how much your gas would cost, here's something that you can do. Your car has a fuel efficiency of 22 miles per gallon. And you want to drive to Albany, which is 159 miles away. How much would you spend on gas? If gas is $3.75 a gallon. An older problem from expensive times, but I'm sure gas will get that expensive again. So, my starting amount is my 159 miles that I'm going to drive. My ending amount is, I want this to come out in dollars. I want to find out how much I'm spending. So, first thing I want to do, since I have miles on top right here, I need to get miles on the bottom down here. So I'm going to pick a conversion factor that has miles in it, and will allow me to put miles on the bottom. My conversion factor that's going to have miles in it is right here, my 22 miles per gallon. So I'm going to do 22.0 miles in 1 gallon. I can assume that this 1 gallon is an unlimited sig fig for this particular problem. Good to go on that one. Now, what that allows me to do is get rid of miles. Now I have gallons. So the next thing I need to know is how am I going to get rid of gallons? Since gallons are up top, I want gallons on the bottom. So in order to get gallons down here, I need a conversion factor with gallons in it. I'm going to pick that one. So 1 gallon is going to cost me $3.75. Let's get rid of my gallons. So now what I can see is the only unit I have left is the old dollar sign, so I'm good to go. So mathematically speaking, you're going to punch into your calculator 159 times 3.75, and you're going to divide this by 22. So what this should give you is 27.1. That is the answer with the appropriate number of sig figs. To make this look more like money, I did actually cheat a little bit and throw that 0 on there. That's not sig fig correct, but that is what money looks like. So I can assume that this is going to be pretty darn close to $27.10. Another example, we have 9 class periods here at Marcellus High School. If you zone out 5 minutes of every class period, how many hours of education will you have missed in a 180-day school year? So I'm going to start by saying, okay, this is a little bit weird, a little bit different. This is a slightly different problem, and much more complicated than most things that we'll do. I just kind of thought it was funny and you might enjoy it. I'm going to zone out for 5 minutes of every one period. Now we haven't started with a fraction yet, so that's a little bit different. I want to know how many hours per year of education I'm missing out on. So we can actually have a fraction in our ending amount. So the first thing I want to do is I can get rid of either minutes or periods. It really doesn't matter. So let's get rid of minutes. Since minutes are on top, I need to put minutes on the bottom. One thing that I know I want my answer is hours. So you do need to use your brain a little bit sometimes. One thing that I can easily do is say, hey, I know there are 60 minutes in 1 hour. So that will allow me to get rid of my minutes. Now I have one of the units that I want in my answer, which is my hours. So the next thing I want to do is I need to get rid of that period. So I have to go back to my question, and as far as teaching periods go, we have 9 of them per day. So since periods are on the bottom, right here, I got the periods up top. So there are 9 periods in every one day. That allows me to get rid of periods.
Brian Riesler, please stop by the main office.
Sorry about that. So now I've got hours on top, which I need, and I've also, but I need my days to go away and turn into years. So you hopefully know how many days are in a year. We're actually not going to use calendar days, though. We're going to use our 180 school days. So we have 180 days, and I know this is plural and the other one's single, but they will cancel out over 1 year. This will get rid of my days. So mathematically speaking, what we're doing here is we're doing 5 times 1 times 9 times 180 over 60. Basically like a giant fraction. So if you go ahead and you punch this in, no. Sorry, a little confusion there. This will be 135 hours. You have unlimited sig figs really from your conversion factors. Really should only have 1 sig fig. I kind of lied a little bit here, but for the sake of our calculations, this would be 135 hours per year. With appropriate sig figs, I guess you'd round that down to 100, but I think it sounds better when you're missing a little more. It might make you think about zoning out. We're going to do 2 more problems together. The distance from Marcellus High School to Destiny, USA is 14.53 miles. What is the distance in meters? So you might want to just take a minute and see if you can figure this one out, and I'll put the answer up in just a moment. So our possible conversion factors, we could have 1.61 kilometers over 1 mile, or 1 mile over 1.61 kilometers. We're also going to be using 1,000 meters as a kilometer, or a kilometer is 1,000 meters. My starting amount is going to be my 14.53 miles. In order to get miles to go away, I'm going to put my mile on the bottom, and that turns into 1.61 kilometers. I need my kilometers to go away, so I'm going to put my 1 kilometer on the bottom and my 1,000 meters on top. Kilometers cancel. And then when I do my math for this, 23,400 meters with appropriate sig figs. I'm actually going to stop there and divide this into 2 videos. So make sure that you check out part 2 where we will also talk about more unit conversions.